Okay, hi everyone. I'm Yusuke KUOKA. I'm a maintainer of Kubernetes and Helmfile, Brigade, and EKS control. And I'm not good at speaking any human language. I'm very good at creating bugs. So, do you understand me at all? Okay, thank you. Okay, I'll speak about this specifically. So, how to deploy your apps in a way that it's cheap and fast and safe. I think it's very general questions you want to achieve in your deployment pipeline. So the vocabulary I'll be using in this presentation is this 5 and 6. And the continuous integration, you say CI. This is about ensuring your code always ready to be deployed. And code CI means that apps and config, including Kubernetes manifest, Helm releases. And continuous delivery means you make changes visible to customers often. And this doesn't necessarily mean automatic. So you usually use feature flags, one-click deploy rollback for this. And the third thing is continuous deployment. It's about automated continuous delivery, like unattended deploy and rollback. Do you know GitOps? Ever heard of GitOps before? Yeah, okay, good. So CIOps explained in contrast to the GitOps. CIOps about doing operation like deploy from your CI system. One problem is that it's prone to failure. And GitOps is about doing operation like deploy via Git commit. You get idempotency and reliability extra of them compared to CIOps. Recently emerging ChartOps is about, in my opinion, it's about triggering CI jobs or Git commits via chat message or issue peer comment. Okay, so today we are solving these problems. Our deployment pipeline should be should have less cost. That means less infra cost and less operational cost. It should have more speed, more throughput. It's about throughput of builds, less latency. You should also have more safety. Your deployment pipeline shouldn't induce any downtime and shouldn't expose credentials. So challenge we have is these three. Make it cheaper with spot preemptive instance. Do you use AWS or GCE? Anyone? So maybe you've heard of spot or preemptive instance, and that is interruptible at any time, but very cheap. And observability. Make it faster with auto-scaling, improve the content image casting files. Make it safer with declarativeness and suspend the rollback on failure. And finally, increase the pipeline. I don't deep dive into every topics here, but in this 20 minutes presentation, I'll be introducing self-hosting CI/CD with Flags, Brigade, making it faster with Kubernetes and its primitives, and make it safer with Helmfile, Flagger, and Flags, Brigade CD. Okay. TLDR for this talk is just for. Please do CIOps better. I don't force you to migrate to GitOps, but if you do CIOps, you can do CIOps better. After that, you can migrate or do better GitOps. Just my opinion, but you can choose to use Helmfile for CIOps and GitOps, and you can choose to choose Brigade for CI and CD. It is forced. Okay. So my goal today is that enable you to build your own good enough CIOps or GitOps pipeline. I'll give you just ideas, options, and examples. Okay. So the first question is, how do you will you deploy today? Okay. Think about that a second. Okay. In my opinion, deployments to Kubernetes in a nutshell is basically about reconciliation loop of Kube control, Helm, and customers. Okay, and continuous deployment is a kind of reconciliation loop. It reconciles your current cluster state to the desired state. And we usually use Okay, so we usually make our deployment process look like this. So you reconcile by deploying fixes or delivering features. And you, after the deployment, you observe alerts or pull requests or something to reconcile another deployments. And we have a few reconciliation options. If your infrastructure is coded statically, you can just use kubecontrol apply, prune, and apply your Kubernetes manifest. In this model, every deployment missing your desired state are pruned from your cluster. And everything in your current state is updated accordingly. If anyone using Helm plugin install for your deployment pipeline? Anyone? Okay. So if you want to reconcile your cluster state with Helm, you must use Helm upgrade install. This is the only way to reconcile your cluster with Helm. This basically works by installing your chart if missing in your cluster, and upgrade your Helm release if it does exist in your cluster. Anyway, using customize for your deployments, maybe one or two. Okay, in this model, you just use customize the builder for your Kubernetes manifest, and you kubecontrol apply prune with it to deploy. Okay. Maybe many people in this room is using these dynamic reconciliation options. The most basic model is that kubecontrol based. You generate manifests from templates. In your templates, you use sed or shell script or Ruby script, whatever you like, to generate manifests from your templates. And finally, in kubecontrol apply. In a Helm-based option, you generate various YAML files with sed or shell script or something, and you run Helm upgrade. In customized-based model, you generate resources or patch files dynamically and apply customized build. Okay, so more concretely, your Kubernetes deployment process today should look like this. You observe your cluster state, and you deployment run kubecontrol or Helm, or maybe customize. Okay, so I don't know what solution exactly do you use today, but existing CI system includes Travis, Sarkozy, Jenkins, Concourse, Drone, or Brigade. So maybe you will be running one of these three tools in this CI. And if you do GitOps, you may be using Flux or Argo CD or your in-house Kubernetes operator for deployments. Okay, so I don't deep dive into each tool used, but a common problem for CI/CD is that it has low tool coverage. So maybe you need to tweak your pipeline for each tool you use for deployments. If you use Kubernetes manifest for deployments, you need to script your deployment pipeline to use that. Or if you use Helm, you need to script your deployment pipeline accordingly. And there's a problem that if you go for more dryness, it becomes very hard to review. Anyone use Terraform or Pulumi or AWS CDK or any scripts for generating manifest? Okay. So coding your infrastructure makes it very dry, but it's very hard how it affects your cluster. So this is a problem. It becomes hard to handle failure. If you run kubecontrol Helm or customize in the very end of your deployment pipeline, you are not sure where to restart your pipeline on failure. And the debugging is often hard. Okay, so the solution I'll be presenting here is that do GitOps and use a single tool for deployment and do templating for dry, but flatten templates for reviews. And do prepare your web UI for permalink to build, deploy, and do enable browsing logs per build or deploy. Okay. So I'll be explaining GitOps. Okay. The simple GitOps pipeline look like this. You have app repo and generate the config. Maybe it's kind of a directory containing Kubernetes manifest, the CI, and applies it to be your Jenkins or Flask. Okay, so it looks like this. And the GitOps upsides where only the GitOps controller is able to deploy apps. So this reduces your attack surface to your cluster, and it's very secure because its credentials are exposed to the GitOps controller only. For example, if you're using Circle CI Travis public source to your deployment pipeline, you need to expose your secrets to the third-party service. It's a kind of security nightmare. Okay. Finally, every changes are recorded in Git for reviews and audits in GitOps model. That's great. And one gotcha for embracing GitOps is that code repetition and tool agnostic is hard. So Flask has Helm operator for reducing code repetition. That you can deploy Helm chart via Flask via Git commit. And Argo CD and Flask has experimental config management plugins that allows you to hook into Flask and Argo CD to run customized build or Helmfile, Helm command to generate Kubernetes manifest for deployment. Okay, and that's the basics. And today I'll be entering Brigade and Helmfile. Brigade is event-driven scripting for Kubernetes. It's a CNCF sandbox project, and it's kind of a scripted workflow engine. So it actually runs a Node.js runtime inside a pod and gives it kind of JSON document as an event. And you use JS for scripting and Node modules for use. And if it says simply, it can be said as a Kubernetes jobs on thread. You get per-build jobs and web UI and easy retry and extensive framework for Kubernetes jobs. Okay, so this is a basic Brigade.js kind of your deployment pipeline definition written in JavaScript. The first line, you hook into the Brigade event system. So here, events on push means that on every Git commit made to your Git repository, you run this snippet of JavaScript code. In the third line, urepo helmfile v 0.83.0. This is a Docker image you will be running in your Kubernetes pod, and you'll be running this sequence of shell script, make dir, cp, cd, and finally helmfile apply command. Okay. Finally, there is an extension to Brigade that is called Brigade CD. This works like this. It watches custom resource changes and reconciles the custom resource with running Brigade jobs. Okay, and finally, Helmfile. Helmfile is a declarative spec for Helm releases. It is a CLI. It doesn't have a server, so it is very easy to install. It's a kind of an infra code tool, so it can be comparable to Terraform or Terraform. Okay, it is very CI/ops optimized, but it can be used to GitOps too. The great point about it is that it has very experimental support for customized and Kubernetes manifests as Helm charts. Okay, it makes your Helm release very declarative by giving you these configuration syntaxes. You can define what repository you use in your deployment. This is a kind of Helm chart repository. What releases, this is Helm release you'll be installing to your cluster, and Helm default arguments passed to Helm command, and finally environments. You need to deploy production environment and staging environment. Or you maybe need a prerequisite environment. You can define every environment under this environment section. Okay, and you can also use Helmfile template for templating your desired state. So the last two, last two lines. It's very hard to read, but you see you can use Go template expression in your YAML to generate your YAML. Okay, and finally, it has a Helmfile build command for generating the final static YAML files from the templates. So it is very easy to review the result. Okay, so it can be say it's like Terraform, but for Helm. So if you have used Terraform before, Helmfile build looks like a Terraform plan, and Helmfile apply looks like Terraform apply. And here, Helmx is a Helm plugin for installing any directory containing Kubernetes manifest and customization as Helm chart. So to use it, you can just add X before any Helm command, and it just auto detects config type, whether it's remote or local chart or Kubernetes manifest directory, customization directory. So applying this to your reconciliation loop, you can just periodically run Helmfile diff and Helmfile apply, and you get automated reconciliation loop for any deployments writing Kubernetes manifest, Helm charts, and customization. Okay, with that you can build a CLOps look like. Okay, it triggers the Helmfile diff via pull request. You merge it, and Helmfile applies it. If you find any issue after deployment, you can submit another pull request for revert. Okay, so if you build a GitOps pipeline with Helmfile, the process looks like this. You send a pull request, and the CI pipeline runs a Helmfile build, and it commits the resulting Helmfile YAML into feature branch. You pull request the feature branch, and Helmfile diff on CI gives you the differences between the current state and the desired state. And reviewing that, you merge the pull request, and finally Helmfile apply deploys the desired state. That is reviewed, and finally you revert if necessary. Okay, so you can use any CI/CD pipeline system to implement this, but if you are using Brigade for building this pipeline, Brigade appears in several places. You send pull request, and Brigade runs Helmfile build, and it commits and pushes your git commit. Another pull request triggers another Brigade job that runs Helmfile diff, and if you merge it, Flags detects the new git commit, and it creates a new custom resource object in Git, and it runs another Brigade job. So what I would say here is that you can enhance GitOps pipeline with Brigade and Helmfile. With Helmfile template for dryness and Brigade for web UI, you have a reduced operational cost, For infrastructure, in-cluster Brigade CI/CD pipeline, leveraging cloud preemptive virtual machines, you can have reduced infrastructure cost. Deploying your CI/CD on Kubernetes for leveraging Kubernetes primitives like cached Docker image and cached build assets in volumes, container volumes, you can have extra speed or speed of your deployment pipeline. Sorry. Okay. Oh. Finally, spots are green. Okay. Finally, running Helmfile build for declarativeness and reliability, and deploying your in-cluster Brigade CI/CD for limiting credential access to only to your infrastructure, not third-party services like Circle CI, next to extra safe. Okay, so I'm finishing my talk, but if you are very curious about how GitOps and for this pipeline works, you can start by reading great blog posts from Weaveworks. Weaveworks writing about GitOps and anti-patterns, including CIOps. There's a very detailed explanation of what's the difference between CI, CD, CD. Okay, so I talked about state of the art of GitOps with Helm. It's basically about GitOps plus dryness and plus tool agnostic. What I want to say in this presentation was just 4 points. So you can do CIOps better by using Helmfile on CI of your choice. Anyone using Jenkins or Circle CI, Travis CI on your pipeline? Okay, so you can just start using Helmfile on your CI system of choice to make your deployment very dry and also reviewable. If you want to make your CIOps pipeline more reliable, you can migrate to GitOps. You can start a very simple GitOps pipeline with flags, and you can make it a little more dry with Helm operator plus flags. You may be here. What I'm suggesting that you can use flags, Brigade, and Helmfile, all three for extra observability and dryness. I'm not forcing you, but I can recommend Brigade for shared infrastructure for both CI and CD. And you can also try Helmfile for a common tool for CI and CD. So if you are using only Helm charts for your deployments, you can maybe you are maybe happy with just running a bunch of Helm upgrade install commands in your script. But if you have a more complex infrastructure and you need to build many environments in your Kubernetes clusters, you'll be happy using Helmfile. Okay, so my goal today was enable you to build your own good enough CIOps and GitOps pipeline. So I give you ideas, options, and examples. So did I enable you that? So I recommend you to give it a try. There's easy tutorials for Helmfile, Brigade, and also Flux. And you can also try my demo hosted under GitHub, Mumoshi Brigade Helmfile demo. And you can also ask me anything in Slack channel, in Cloud Pose, Kubernetes, and Weaveworks Flux channels. Okay, thank you. Do I have some time for a question?
I'm not exactly sure if I understand the step in your pipeline where you apply it, where you have Flux and Brigade doing two things at the same time. No, not that far. It was further. Yeah, this one.
Okay.
One back.
Okay.
Yes.
I see. Okay.
The periodic apply. How do Flux and Brigade interact here?
Okay. Flux watches for Git repository and applies custom resources specifically made for your deployments. So you basically write a Helmfile YAML content in a custom resource, and Flux duplicates the Helmfile YAML content from Git repository to Kubernetes custom resource object. And finally, you can write Kubernetes operator like a Brigade CD I've introduced to reconcile the custom resources into your Helmfile deployments. So you watch GitOps and reconcile the cluster state, and in cluster Brigade pipeline reconciles by watching the intermediate state stored in Kubernetes cluster, and finally creates Kubernetes primitives like ports and deployments and everything else by running Helm upgrade command. Okay, so maybe you can ask me anything in text so that I can better explain it. Anything else?
So on this slide, what's the difference between the two pull requests?
Sorry, pull request?
There's the two pull requests.
Okay. So, how do I explain it? So the first pull request can be made to a template repository, and that contains a template of your infrastructure.
Okay.
That can be including your application repository, and so you need another Git repository for just containing exact code or exact static configuration file to describe your cluster, so that you can audit and review every exact changes made to your cluster.
Releasing a chart, an individual chart.
Individual?
That's a Helm file.
Yeah, maybe you'll be including individual chart and the Helmfile Go template in the application or template repository, and you generate the final static YAML files in the config repository, and that is sent in the second pull request. Thank you. So anything else? Okay. Thank you for coming.